All right, this is lesson 24, fractional equations and overlapping triangles. All right, so the first part is not a whole lot new. What's different is instead of just having one term, a monomial, a single term in the numerator, we now have a polynomial. Not in the first example, however. We have mixed numbers. So it's 4 1/2 x minus 3/5 equals negative 1 1/4. I teach this from the beginning of the year so that there doesn't have to be a change. But what's the first step to solving this equation?
Make log same denominator.
No.
Make them not mixed numbers.
Correct. Improper fractions. So let's make everything an improper fraction. So 4 times 2 is 8 and 1 is 9/2 x minus 3/5. That's negative 5/4. So first step, mixed numbers. Not mixed numbers, improper fractions. Okay, now my rule is, and the rule that should be is, you have an equal sign, you're eliminating the denominator. No equal sign, you're going to a common denominator. But if we have an equal sign, we are eliminating it by what would be the common denominator. So you take your largest denominator, 5, and you count up until all of these denominators go into it. So what would be the common denominator? 20. That's what we multiply every term by to eliminate the denominators, all of them. And before we multiply, we always simplify. So 2 goes into 2, 1, and into 2010. 5 we can simplify as 1 and 20 as 4. And on the other side of the equal sign, we can simplify 4 to be 1 and 20 to be 5. Now once we've simplified, all of our denominators are eliminated, and we can multiply. So we end up with 90x minus, that's 4 times 3, 12, equals negative 5 times 5, negative 25. I add 12 to both sides, leaving my x value on the left-hand side. Negative 25 plus 12 is negative 13. Then I divide by 90 on both sides. X equals negative 13 over 90. And then I ask myself, can I simplify? That is in its most simplified form, negative 13 over 90. And so you leave it there. All right, that's the easy one. The second example has a binomial in the numerator. We're still going to eliminate the denominator, but now we have to distribute whatever we're multiplying it by to both terms in this binomial right here. Minus 3/2 equals 1/3. Okay, 3/2 and I wrote 3/5. I said 3/2 and I wrote 3/5. All right, what would be the common denominator between 5, 2, and 3? 30. So that's what we're going to multiply every term by. 30, 30, and 30. But before we multiply, we always simplify. So we can simplify this 5 and the 30. 5 goes into 36 times. We can simplify the 2 and the 30. 2 goes into 30 15 times. And the 3 and the 30. It goes into 30 10 times. Now here's what's different. This 6 has to be distributed to both of the terms in the binomial. So we're left with 24x plus 12. 3 times 15 is 45. And 1 times 10 is 10. All right, negative 45 and 12 is negative 33, right? It's negative 33. So we're going to add 33 to zero that out. We'll add 33 to both sides. So it moves all of this to the right-hand side. So we're left with 24x equals 43. And then we divide by 24 on both sides. X equals 43 over 24. And I believe that that cannot be simplified any more than it is. All right, one more example, then we'll move on to the next, the overlapping triangles. 24.3. 3x over 2 plus 8 minus 4x over 7 equals 3. Remembering that 3 is just like 3 over 1, so its denominator is 1, so we're just looking at 2 and 7. Well, the only common denominator would be 14, so we're going to multiply every term by 14. Every term by 14, even the 3 on the other side of the equal sign by 14. So this is where mistakes are commonly made, by not multiplying that 3 by 14. Because there's nothing to simplify it with. It's just going to be 3 times 14. All right, we simplify. 2 goes into 14 7 times. And 7 goes into 14 2 times. And then we distribute. So 7 times 3x is 21x. And we distribute this 2 to both the terms. This one's easy because this is positive. If this was negative, then all these signs would change on the other side. I think I've already told you ladies about that. All right. 2 times 8 is 16. 2 times negative 4x is negative 8x. And 3 times 14, that's 12, carry 1, 42. All right, we subtract the 16 on both sides. 42 minus 16 is 26, I believe. Yes, is that right? 26? Yes. And then we can combine our like terms. 21 minus 8 is 13. This one's nice and even. Notice how they've not been, they've been fractions. So x is 2, and that would be our final answer. The other part of this lesson deals with overlapping triangles, and it goes back to geometry. All right, when we have overlapping triangles, first let me draw it and then ask you a few questions. All right, so we have 2 triangles. A, B, C, D, and E. And they're always going to tell us that that one's easy. Here's what we don't know. We don't know that BC is parallel to DE. That's in the next lesson. All right? But we do know that we have 2 triangles. Let me write the values. 4, 7, 9. I think that's X and Y. And this is 6. All right? We do have 2 triangles. We have triangle ABC, which is the small one on top. And we have triangle ADE. So how are these 2 triangles related? Clearly they're not congruent. However, we know that this angle E equals this angle ACB. Is there any other angle that equals? What angle's in both triangles? A. A is in both. and angle A equals angle A in both triangles, right? And if two angles of the triangles are equal, then we know that the third one is equal as well. So the triangles are similar. And similar triangles have proportional sides. All right, so when we're looking at the triangle ABC, we'll write the sides 4, 7, and 9. And we're just going to solve x and y using ratios. All right, the 4. We have to know corresponding sides. What side in ADE corresponds with the 4?
AD.
The whole side. So it's 10. So you're adding those two. And 7 corresponds with 7 plus x. And then y corresponds with 9. Y, Paula, corresponds with 9. All right, we're going to use ratios. So I can say 4 over 7 equals 10 over 7 plus x. And I can cross multiply. That's 70. Remembering that when I'm multiplying 4 by both the 7, which is 28, and the x, which is 4. When I subtract the 28 on both sides, I'm left with 4x equals 42, right? And I divide by 4 on both sides. All right, it's 42 halves, but both of those are divisible by 2. So it's really 21 halves. So x equals 21 halves. Now, when I solve for y, I'm never going to go back and use x. Because if I get x wrong and I use it to solve for y, I'm now going to get y wrong. So always go back to the 4 and the 10, the two that are given. And I'm going to put 4 over 9 and 10 over y. Make sense? Multiplying, cross multiplying. 10 times 9 is 90. 4 times y is 4y. I divide both sides by 4. Both of those are divisible by 2. So y is 45 halves. All right, makes sense how we're going to solve those?